so this is kind of where we left off. We did some general descriptives of the participants in this data set. And so our next step is to determine what our research question is. So I'm going to use an example of one that is just binary, where it's a yes versus no. So let's say that I'm curious whether there are any sex differences in this data set. So um, do females tend to have, be more enrolled in general programs, or are females more enrolled in private schools? And then what are some of the differences in terms of, gender based off of these different testing scores? So what we're going to do is do some chi-squares for our categorical variables, and then we'll do some independent t-test for these continuous variables. So I first like to start off with creating a table so that I can go ahead and have this data ready to go. I'll give it more of a title once I, kind of taking a look at what's this going to look like. And I like to do 4 by 4 columns, and then add the rows as we go, because it's the max that we can add so far. Um, for here, we'll have female and then male, and then in the very last column, we're going to have our p-values. And then in these columns, we're going to have all of the different variables that we could be comparing them by. So the first is going to be race, and then socioeconomic status and program. Since we already know that those are some of the variables that we have, we can go ahead and add more columns to this. Let me make sure that we had all of our programs. They actually fit perfectly. And then the last few that we had to compare them by are, testing um, scores and whether they were in public school or not. And just as we did in the very first one, what we're going to be providing again is mean plus or minus standard deviation, or the n and the percentage. And don't worry, we'll fix the formatting for this. So go ahead and select these columns. We want to make sure that they're centered. It just kind of helps us keep on track. And it just kind of just looks a little bit more generally appeasing. You can also go to this layout tab, just like I just did, and then align this, these numbers towards the bottom. And then my very last step is I like to make it to where these aren't so wide, because we don't need that much room for each of these variables. But we want our very first column to be a little bit wider. And then once everything has kind of aligned to one, row each, we can spread this out to so that each of these has enough space, essentially. So first step, it's proc frequency time again. So we got proc freq, and then data is HSB2. And then for tables, and remember, we're comparing everything by their gender. So it's female times program, female times race, female times school type, and then female times SES. You can do these all separately, a different proc freq for each one of these variables, but it makes the code a lot longer when you do that. And the last step, we put in a backslash chi-square so that we can get our chi-square option for these. And then we go ahead and click run. So let's go ahead and do these categorical data first. And we click the run, and we've got all of this beautiful data popping up. And so let me pull up our little cheat sheet for what each of these numbers actually mean. So this very first one is a comparison of program. So the 1 means it's female, 0 is male, and then each of these program types we have general, academic, and vocational. Just kind of like what I said before. So for the female group, make sure that you guys are getting the correct percentage, because what we're wanting to do is we're wanting to see what percent of females are enrolled in general, what percent of females are enrolled in academic, and what percent of females are enrolled in vocational. So all of these percents going in the column should add up to be 100. So this very first one, we have 24 females enrolled in the general one, and It's a little bit flipped when we kind of look at the actual SAS code. We would be using the row percentage because that is where all of the females are going to be located. So it tells you how many for frequency, percent for the overall total, all 6 different, potential categories they could be in, and then the row percentage, so going all the way across, and then your column percentage going all the way down. So this first one, we have 24 that are female in program 1, which is general, and that's 22%. Generally for percentages, you only give 1 decimal place, and since it's a 0 or a 2, we wouldn't round up for that one. Next one, we have 58 females in the academic program, and that is going to be 53.2%. And then last one is 27, which is 24.8%. Remember to round up for the place that you're rounding up to, 5 or higher. Next we have the males. There's 21 in the general track, which is 23.1%. 47 in the academic one, which is 51.7%. And then there is 23 in the last one, vocational, which is 25.3%. Now for the p-value, make sure you put it next to the program variable name right here. These are all of the different potential programs they could have been in, but we put the actual p-value right next to where the program is. P-value is not significant, 0.97, so you can go ahead and just put in those 2 digits. It's enough to tell us that this is not significant. One thing to keep an eye out for is when we're looking at the frequencies in here, if you see anything that is less than 5, that's a pretty good indicator that we should be doing a Fisher's exact test rather than a chi-square. So do keep that one in mind. And the reason I say that is because I'm looking at race. We have a couple that are a little bit less than that. We can go ahead and pop in these frequencies and percentages, but we'll want to recalculate this or redo this analysis using Fisher's just so we can get an updated p-value. So first one we have Hispanic race, there's 11, same concept here. We're going to go across in SAS but go down in the actual table here. So that's 10.1%. For Asian we have 8, which is 7.3%. For African American there's 13, which is 11.9%. And then for white we have 77, so that's 70.6%. Over here we have 13 for males in the first racial category, which is 14.3%. 3 in the next one, which is 3.3%. 7 in the next one, which is 7.7%. And then 68, which is 74.7%. And the p-value for this one, remember, we're going to come back. And just so that I remember to say something about it, we're going to put a star next to race and say, in the notes, using Fisher's, using Fisher's exact. Let's see, next one we've got school type, so public school, that's the 1 for this one. So we had 91 who are female in public school, which is 83.5%. And then for male, sorry, got a little tripped up for a second, we have 77, which is 84.6%. This one we can go ahead and provide the p-value because the cells look okay. So 0.83, we round up a bit. And then last one, we have socioeconomic status. So we have 32 here, which is 29.4. Middle was 48, which is 44. And then for high, we have 29, which is 26.6. And then for males, we had 15 in this one, which is 16.5%. 47 in the next one, which is 51.7%, and then 29 in the last one, which is 31.9%. And the p-value for this one is 0.10. So trending towards significance, but not quite there. So let's go ahead and redo that one race. I believe it was. Yes, that one race one. We can take out these others because we already, examined them, and we'll write in Fisher so that we can get the Fisher exact test. And then highlight it, press run. Alright, so we have our p-value. Didn't change too much, 0.38, but that's totally normal. So we'll go ahead and put 0.38 for the Fisher's exact test.